we'll look at the types. We will look at what is weight. We'll look at the types of weights. We'll also look at the advantages of weight, the disadvantages of weight, and we'll summarize everything. Then if any of you has got any questions, you can bring them on board. But just to continue, I just want to clarify, can everyone hear me?
Yes, we can hear you.
Okay, cool. All right, so weight command in Selenium. So a widely used open source framework for automation testing is Selenium. When it comes to web automation, the widely used open framework is Selenium. So this ensures that web applications run properly across all browsers and operating systems. So as a result, Selenium has become very popular in the testing industry. So to test our web applications better and to resolve all the challenges we face, it is important to learn certain Selenium best practices while writing the test code. And when it comes to these best practices, one of the most important factors in Selenium C# is the ability to use wait commands. And this helps to reduce the flakiness of tests. So let's see how wait command in Selenium C# can help us in resolving issues in our web applications. Because I think most of you has been facing issues whereby when you're running your code, you sometimes have like exception errors like the element does not exist, Selenium couldn't find your element and all of that. And some of these issues is due to this wait we are talking about. So wait is a very important, one of the important things to know as a QA. So what is wait commands? When it comes to Selenium, wait commands are used to pause the execution of a test script for a specific amount of time or until certain conditions are met. And when we automate a web application using Selenium, sometimes we need to wait for certain elements or pages to load before performing any action on them. If we do not wait for these elements to load properly, the script may fail due to synchronization issues or elements not found errors, which I'm very sure most of you are familiar with this error. And also, wait commands are essential in Selenium automation to ensure that the script runs smoothly without any errors due to synchronization issues or element not found errors. So what are the types of wait? We have types of wait. We have implicit wait, we have explicit wait command, and we have the fluent wait command. So you can see I didn't mention the thread.sleep, which most of you are familiar with, but thread.sleep falls under explicit wait command. But most of the time, that is the easiest to use, and that is what most of us are familiar with, which is not the very best to use. But as we go on, we will get to know about all these types of wait, how to use them, when to use them. And I'm very sure at the end of these sections, you guys will be very confident and you guys will know how to use this command. So let's start with thread.sleep. What is thread.sleep? So when it comes to thread.sleep, it's a method that causes the current thread to pause for a specific period of time in milliseconds. And it can be used to introduce a delay in a program to simulate the time taken by a user to perform an action. So to wait for a resource to become available or to implement a simple form of polling. As we go on, you guys will understand what this polling means. So for example, if you want to wait for 1 second before performing the next action in your program, thread.sleep method is called with an argument of 1,000, which means the current thread will sleep for 1,000 milliseconds or 1 second. So 1,000 milliseconds makes 1 second. That is why we use 1,000. And it's important to note that using thread.sleep is not always the best approach for waiting in C# programs. Instead, it's recommended to use asynchronous programming techniques such as await key and tags.delay to avoid blocking the calling thread and to improve the overall performance of the program. Additionally, using thread.sleep in user interfaces can result in a non-responsive UI and should be avoided. Okay, I mean, everything has got its advantages and its disadvantages. So let's look at some of the advantages of thread.sleep. The first one we have here is control flow. So thread.sleep allows you to pause the execution of a thread for a certain period of time. And this can be useful in controlling the flow of your program and making it wait until certain conditions are met. So like when you're running your script and it's showing an element not found exception, you can quickly use thread.sleep to check if it's from your element, if it's a synchronization issue, or if it's that, like, you don't have a good element and you need to change it, the locator. So that's one of the advantages. And also when it comes to the next advantage, we have resource management. So thread.sleep can be used to improve resource management by temporarily suspending the execution of a thread when it is not needed, allowing other threads to use system resource instead. We have the next one, which is time-based operation. So when it comes to thread.sleep, it can be used to perform time-based operations such as periodic task execution or timing out a long-running operation. Simple implementation is very simple and easy to use. I mean, once you just type thread.sleep and you put in the seconds you want, you are good to go. So it's a method which is easy to use and can be implemented with just a few lines of code. Unlike the other one, like the fluent accession and the implicit, the fluent wait and the implicit wait. So another advantage is also synchronization. So thread.sleep can be used in conjunction with synchronization techniques to ensure that threads execute in a specific order. Testing. So thread.sleep can be useful in testing scenarios to stimulate delays and verify that your code behaves correctly in those situations. What are some of the disadvantages of thread.sleep? So inaccurate timing. Thread.sleep cannot guarantee a precise timing as it depends on the system clock and the operating system scheduling algorithm. Therefore, the actual duration of the thread of the sleep may vary from the specific duration, which can lead to problems in real-time applications. One disadvantage also is wasted CPU time. So when a thread is sleeping, it is not doing any useful work, but it still consumes CPU resource. And this can lead to insufficient use of system resource and can reduce performance of the overall system. Unresponsive threads. So if a thread is sleeping for too long, it can become unresponsive and fail to respond to interrupt or other events. And this can result in a deadlock or other synchronization problem. We also have poor code readability. Overuse of thread.sleep can make the code hard to read and maintain, as it can lead to complex control flow and timing related bugs. And the last disadvantage we have here is alternative solutions. So in many cases, there are better alternatives to using thread.sleep, such as using wait/notified timers or event-driven programming. These solutions can provide more precise timing and avoid the problems associated with thread.sleep. So this is how thread.sleep can be used. When we look at line 22, I mean, we can see it there. So we are just saying in the method, we wanted to click on login menu, and we are saying to it that before it clicks on login menu, it should wait for 5 seconds to click on it. We'll later on go into the practical aspect of it. So let's go to the next type of wait, which is the implicit wait command. And this is the code snippet for implicit wait command, which is driver.manage timeout implicit wait is equal to time wait point, dot from seconds. So what is implicit wait? Implicit wait is a type of synchronization technique in automation testing. And this allows the test script to wait for a certain amount of time before throwing an exception if an element is not immediately available. In other words, an implicit wait tells the testing framework to wait for a certain amount of time before attempting to locate an element on the web page. If the element is located within the specific wait time, the test script continues to execute. If the element is not located within the wait time, the test script shows an exception. So unlike the thread.sleep that when you ask your code or the system to wait for 5 seconds before it executes the next code, when it comes to implicit wait, even when you ask it to wait for 5 seconds, as long as it finds the element, it's not going to wait for that 5 seconds. So let's say if it finds this element within 3 seconds or 2 seconds, the next lines of code will start to execute. And this helps you to run your code faster. So let's say if you have your code or if you have your automation framework in CI/CD pipeline and you have to run your pipelines every morning, imagine if you have maybe 20 or 50 lines of thread.sleep, 5 seconds each. You can imagine how much time it's going to consume for your pipelines to run. That is why it's advisable to most of the time use implicit wait or explicit wait. So the implicit wait time is applied globally to all the elements in the test script and is set once at the beginning of the script. The wait time is predefined value and is typically set in seconds to the code. So unlike thread.sleep that is set in milliseconds, when it comes to implicit wait, it is set in seconds, not milliseconds. And it says here that it is applied globally to all elements. So once you have thread.sleep, implicit wait in your code, most of the time you put it in your webhooks, your base test, which is like the block of your code. So with implicit wait, you don't apply it in every line of code. No, you don't do that. You only apply it once, and most of the time you apply it in your hooks folder. So what is the advantages of implicit wait? Simplicity. Implicit waits are very easy to set up as they only require a single command at the beginning of your test script. So just like I mentioned, with implicit wait, they are very easy to set up. Once you set it up in your test script, that is it. It's global application, sorry. Implicit waits are applied to all elements in the test script, which can be very useful when testing a large web application that contains many dynamic elements. It also increases stability. Implicit wait helps to make your test script more stable by preventing the WebDriver from throwing exception when an element is not available immediately. It reduces code complexity. By using implicit wait, you can reduce the amount of code needed to handle timing issues in your test script, which can make them easier to read and maintain. We also have improved text execution speed. Implicit wait can help to speed up the execution of your test script by preventing unnecessary delays caused by the WebDriver waiting for elements that are already available. So let's look at some of the disadvantages of implicit weight. Increased time execution. So if the implicit wait time is said to be too long, it can increase the overall execution time of the test script, which can be insufficient and slow down during the testing process. We also have unpredictable wait times. So implicit wait are not very precise, and the wait time may be longer or shorter than expected, which can result in unpredictable test execution times. So just like I mentioned, I mean, with the thread.sleep, when you use thread.sleep and you set it to either 1 second, 2 seconds, or 5 seconds, you know very well the number of seconds it takes the code to execute. But with implicit wait, because it doesn't wait for that 5 seconds, you can't really tell if it picks up the code on the second or the third or the fourth. You can't really tell. So difficult in debugging. When using implicit wait, it can be challenging to pinpoint the exact cause of the synchronization issue because the wait time is not explicitly defined in the code. We have breaks or false positives. So an implicit wait can sometimes cause a test to pass, even if the expected behavior is not actually occurring. So for example, if the test script is waiting for an element to become visible, but the element is present but not visible due to a coding error, the test may pass even though there is an issue. It also has the limited flexibility. So implicit weights are applied globally to all elements, which can limit the flexibility of the testing framework to handle synchronization issues on a case-by-case basis. Right, so this is how you also use or apply implicit weight in your code. So once you write this block of code, then you are good to go. Let's look at explicit wait command. So what is explicit wait command? Before we look at that, this is the block, sorry. Before we look at that, this is the block of code on how to use explicit wait command, but we'll go to the practical aspect of it for everyone to see. So what is explicit wait command? Explicit wait is a technique used in software testing and automation to wait for a certain condition to occur before executing the next step in the automation script. So unlike implicit wait, which waits for a fixed amount of time, explicit wait waits for a specific condition to be met before proceeding. For example, let's say we have a web page where a button is enabled only after a certain amount of time has passed. So with an explicit wait, we can tell our automation script to wait for the button to be enabled before clicking it. And this ensures that the button is clicked at the appropriate time, regardless of how long it takes for it to become enabled. So unlike the implicit wait that it has to maybe wait for an element to click before it runs the code, with explicit wait, you can tell it to do the exact thing you want. And in this example, it says that let's say we have a button which is enabled only after a certain amount of time has passed. With explicit wait, we can tell our automation script to wait for the button to be enabled before clicking it. And this ensures that the button is clicked at the appropriate time, regardless of how long it takes for it to become enabled. I know some of you might be a little bit confused between the implicit wait and the explicit wait, but we'll look at the difference. And when we get to the practical aspect of it, you have a grasp of what I'm talking about. So explicit wait can be implemented using various methods, such as the WebDriver wait class in Selenium, We can, in Selenium WebDriver, we can also wait for a specific condition to be met within a specific timeout period. The condition can be anything from the presence of a web element to a specific text appearing on the screen. So, sorry, this thing is coming. Okay, so when it comes to the expected conditions in explicit wait, we can use titles. We can tell it that when it comes to title, it has to an expectation for checking the title of a page, title contains. So we can use all this list of words we have here to wait for our script before they execute. So we can use the title, we can use the title contains, we can use URL to be, we can use URL contains, we can use the presence of elements located. We can use all of these in our explicit wait. So what are some of the advantages of explicit wait? It's improved test stability. With explicit wait, we can ensure that our automation script waits for a specific condition to be met before proceeding with the next step. And this reduces the likelihood of flaky tests or false positives caused by race conditions or synchronization issues. Reduce test execution time. So by using explicit wait, we can avoid hard-coded sleep statements in our automation script, which can unnecessarily increase the test execution time. And instead, we can wait for the specific condition to be met, which can reduce the overall test execution time. The other advantage is also better error handling. So when it comes to explicit wait, it allows us to handle errors more gracefully. So for example, if a web element is not found within the specified timeout period, we can throw a customer exception with a clear error message instead of a generic timeout error. More precise timing. So with explicit wait, we can specify the exact condition we want to wait for, such as the presence of a web element or a specific text appearing on the screen. This allows us to time our tests more precisely and ensure that they are executing as expected. What are some of the disadvantages of explicit wait? Slower execution. So explicit wait can slow down the execution of automated tests because they force the test to wait for a specific condition to be met before proceeding. And this can be problematic if the wait time is too long or if there are multiple explicit waits throughout the test. Brittle test. So explicit waits can make tests more brittle because they rely on specific timing or conditions to be met. If the timing or conditions change, the test may fail, even if the functionality being tested is still working correctly. Debugging issues. Debugging issues can be more difficult with explicit wait because it may be unclear whether the issue is with the wait or with the application being tested. This can make it harder to identify and fix issues in the test. Difficulty in handling dynamic elements. If the elements being tested are dynamic or change frequently, it can be difficult to determine the correct timing or conditions for the wait. This can lead to unreliable tests or false positives. Also, the last disadvantage we have here is overuse. Overuse of explicit waits can result in code that is difficult to maintain and modify, as well as tests that are slow to run and prone to failure. It's important to use explicit waits judicially and only when necessary. So this is a sample of how you can use explicit wait in your code. So let's look at the difference between implicit and explicit waits. So an implicit wait is set once for the entire WebDriver sections, and it applies to all elements. It instructs the WebDriver to wait for a certain amount of time before throwing a no such element exception error. This means that if an element is not immediately available, WebDriver will wait for the specific time to allow the element to become available. On the other hand, which is explicit wait, an explicit wait is applied to a specific element and conditions. It allows the WebDriver to wait for a certain condition to occur before proceeding the next step. The condition can be anything from waiting for an element to be visible, for it to be clickable, or any other custom condition. So explicit wait is implemented using WebDriver wait class and can be customized to wait for a specific time or a specific element or a combination of both. So this is like the main difference between implicit and explicit wait. Right, so the last one we have here is fluent wait command. So what is, okay, so this is the code snippet for fluent wait command. And let's look at what is fluent wait command. With fluent wait command is a feature of Selenium, a popular web-based automation framework, which allows you to wait for an element on a web page to become available before interacting with it. Unlike a static wait, which waits for a fixed amount of time before proceeding, a fluent wait allows you to set a maximum amount of time to wait for an element to appear, as well as specify how frequently Selenium should check for the element available. Overall, a fluent wait can help improve the reliability and stability of your web application script by allowing them to adapt to the dynamic behavior of web pages. So with the fluent wait, it has something called polling interval, all right? So with this polling interval, once you have set the time for your fluent wait command, let's say 10 seconds, you can set a polling interval which runs in milliseconds. So let's say you can set a polling interval that every 1 second within this 10 seconds, Selenium should check that it can find this element. So with the explicit wait, we only tell Selenium that it should find this specific element, or this specific element should appear within this range of time, or it should appear until it appears. Selenium shouldn't close it or run the next block of code. But when it comes to fluent wait, you tell Selenium that, oh no, sorry, I don't know what happened to my screen. Sorry. So yeah, just like I was saying, when it comes to fluent wait, you tell, sorry guys, I have to stop sharing the,
You can restart the PowerPoint, maybe it will come back.
yes, I don't know. Let me just check it from my end. With, okay, Rose. Yeah, so with a fluent wait, you can tell Selenium that, okay, I want you to locate this element within 10 seconds. But within these 10 seconds, every 1 second, ensure that you find this element, or this element appears. If it appears within this 1 second, take it or move on to the next block of code. But if you don't find it, continue to wait for this 10 seconds. Okay, I'm back. Yeah, if you don't find it, wait for this 10 seconds, but check in another 1 second if you can find it. So for every 1 second, it's going to check for this element, or is going to ensure that this element is appearing before it will move to the next block of code. I don't know if I'm sort of like, if you guys are getting it, but when we go into the practical aspect of it, trust me, you guys will get a better grasp of it. But yeah, that's one of the advantages of FluentWait. It has a polling interval where you can tell Selenium that, okay, you know what, I've set this for 10 seconds, but within every 1 second or 2 seconds, ensure that this element is visible. If it's visible, close don't wait no more, like move to the next block of code, execute the next block of code. But if it's not there, check in another 2 seconds to see if you can find it. So if it checks this 2 second, so let's say 10 seconds, so 2 seconds, like you can search for it like 5 times. So if it searches for it 5 times every 2 seconds and it doesn't find it, then it will tell you that, okay, I couldn't find this element, or this element is not visible. So yeah, that's pretty much how it works. Let's look at some of the advantages of FluentWait. So flexibility. FluentWait allows you to set up the maximum wait time and polling frequency for each specific element, which gives you more control over the wait time and makes your code more flexible. Efficiency. So FluentWait can save time by not waiting for the entire time period you set, and instead wait until the element is found or the maximum time has passed. This can make your code more efficient and help improve the overall performance of your test suite. Resilient. FluentWait can handle dynamic elements that may appear or disappear at different times during test execution. So by using FluentWait, you can ensure that your tests are resilient to change in the page structure and the behavior of the web application. Better error handling. FluentWait provides more detailed error messages when an element is not found or is not clickable. And this can help you quickly identify the cause of the failure and take the necessary corrective action. So let's look at some of the disadvantages. Performance overhead. FluentWait is a more complex method of waiting, and it can be resource intensive, especially when used on large or complex web pages. And this can result in slower test execution times and increased memory usage. So potential for timing issues. Although FluentWait can be configured to wait for a specific condition to be met, there is still a chance that the timing of the condition may be off. For example, if the wait time is set too long, the test may wait longer than necessary, potentially leading to false positives. Conversely, if the wait time is set too short, the test may not wait long enough, resulting in false negatives. So another disadvantage is also code complexity. So when it comes to FluentWait, it requires additional code to be written, and it can be difficult to set up and configure properly. And this can be a disadvantage for developers or QAs who are new to Selenium or are unfamiliar with FluentWait. So unlike the thread.sleep and implicit wait, FluentWait is a little bit complex. But once you know it, once you just have the block of code, you should be fine. And debugging issues. So FluentWait can make it difficult to troubleshoot issues that arises during test execution, as it adds an additional layer of complexity to the test code. And this can make it challenging to pinpoint the root cause of issues that occur during test execution. So this is an example of how you can write your fluent weight in your block of code in your automation. So we'll also look at it. So summing it up, I think we now understood how some web application could take more time to load than others. And this happens when the elements are built using Ajax or any front-end framework. However, this causes hindrance in our testing, and thus we don't get a flawless testing experience. Some of you really get frustrated, when you are executing your code or your automation, and it's not like you are not getting the green tick, driving you crazy. And sometimes it's just because of these weight issues. And therefore, wait commands do really play an important role in Selenium automation testing to resolve this, as it pauses the test until we get a specific ready for testing in the DOM. However, it also increases the time of execution of our test. Yeah, I think that is it with the theory. So I don't know if anyone has got any question, but I have a sample framework here where I use the explicit weight, but I don't